Hello everyone, and welcome to this video recording I'm making about a smart parking prototype that I built that I wanted to demonstrate for everyone. So what I have is some physical sensors, and I'll show you this sensor right here. This is the SKMicro Discovery board, which is for IoT use cases. And I'm trying to zoom in. See that little black rectangle up there? That little black rectangle is a little rangefinder sensor. And SKMicro advertises it as the world's smallest rangefinder. What it can do is within a distance of about 2 meters, it can tell you the distance to an object that's in front of it. And so in order to build this demonstration, what I wanted to do is program that sensor board to send data into an MQTT broker that's a common IoT communication protocol that'll allow me to pick up the data, see what the distance is of any object in front of me, and then use this hardware layout as a smart parking interface with some software that will combine the GPS coordinates on a smartphone to correlate that information with the hardware to identify the person who's actually pulling into the parking spot if possible. So to program the sensor itself, the way this development board works for SKMicro is you have to write a bunch of C code and program the firmware directly. Now that's everything on the chip. That's the Wi-Fi connection and also the functionality. So things like reading the sensors, initializing a Wi-Fi connection, creating an MQTT stream, and all that other stuff. So I have not written any C code in about 20 years. I actually found sample repositories in the embed.com. That's the repository of source code. This is an IDE that helps program these type of boards, these type of kits. And then I sort of just stitched all these different sample applications together and was able to initiate a MQTT data stream into an MQTT broker, and then I configured a VANTIQ connection to that MQTT broker in order to pull that data. So the way this works is I am getting a data stream about once every 10 seconds, as you can see here in this message. It includes the sensor ID, the distance, and the temperature. From there, what I want to do is build out my whole smart parking application, which is want to be able to determine when that distance value changes if there's an object in front of me that I can establish it's a car. I don't want just a person who's walking in front of me. I want there to be a car actually there. So it has to be in that state for a number of seconds or minutes even. And then I want to do GPS tracking on nearby individuals' phones to see if anyone has entered that location recently, and then I'm going to correlate the two. And I will show you how I did that. So I'm in the Eventik platform, and this is our platform that allows us to develop use cases such as this one. And I'm going to use the graphical programming tools to program out these various scenarios. So I've also created a client application. This is a web application that uses the data that'll show me if the parking spots are open and filled. So before I get into the application, let's do a quick demonstration. Let's see if I can get it. There's my car, and my car is going to pull into my parking space, just like that. And then if we look at the data stream here, we should be able to see that the distance has dropped from either 0, and the maximum range is about 2,000 millimeters, so it's got about 2 meter range, to 147 millimeters. And that triggers our application to say that a spot has been taken. That triggers this other application that is starting to do my GPS tracking. I'm going to run a VANTIQ application that I'm using for push notification alerts. You can see it has identified me, sent me a push notification that I am parked in space A2, and then we can do a bunch of other stuff beyond that, should we choose, such as asking if we want to do electronic payment for parking, or maybe even add a whole additional bunch of value-added services like suggesting places to go to eat, or directions to the nearest shuttle, or even reminding the person where they parked when they re-enter the geo coordinates of the parking lot location itself again. So I'm going to go ahead and maximize my screen here. And I'm going to just sort of step everyone through real quickly how I built this application. And also I'm going to jump over the HUD here, and you can see now it says that that space A2 is now occupied. It even lists the occupant's username, which is me, Pat B. All right, so to create this application, we first have to identify the data stream, and like I said, I'm connecting to a MQTT source, and I'm using this graphical programming boxes to do essentially all the development work for me, so I'm not actually writing any code. To give you some idea, when I get down to the location tracking bit of it, all I have to do is fill out a few boxes about my georadius distance, that once I enter that distance, I'm found, and if I'm outside that distance, I'm not found. And a list of users, which I'm using a procedure, which is a coded statement that I'll show you that will give me all the drivers. And that's it. I don't have to do any actual coding. But if I show you what the coding looks like, these boxes just represent really giant blocks of code. And this is the location tracking box of code, if you will, and it's kind of customized when it gets generated for my particular project. But you can see it does a lot of stuff. And I don't have to write any of this stuff. I just have to add the box to my application that says I want location tracking, specifies some of my parameters, and then a list of users that I want to do location tracking on. In this case, I'm doing location tracking on a database that has a bunch of drivers. So basically everybody who's registered in my system who is currently running the parking application and has GPS turned on their phone will automatically be tracked, and therefore can automatically be associated with a parking spot using this methodology. So after that, I'm doing a data enrichment. And I'm doing the data enrichment because I don't want to have to program out everything on my sensor. As you can see, the C programming is painful enough as it is, but every time I make a change, such as refining the GPS location or adding some data that I need, I don't want to have reprogram that. So what we actually did here is we created a lookup reference table that I call parking spots that lists the space ID and the sensor ID. And so that's how I'm going to associate the sensor, which has a ID, as you can see, being broadcast in its delivery, with the space and also with its GPS location. And that is important because I need to set that as my focal point for my georadius, so I know when a person is inside that particular georadius using the GPS coordinates on their mobile device. As a parking space is being filled, that correlation will allow me to detect who the individual is. So I have this enrichment, which allows me to combine those two things. So I just tell it that I want to combine parking spots, and I want to combine it by sensor ID. And I'll add all that additional information, such as the parking spot and the GPS coordinates to the data stream. Then I can throw it into a table, which I use for my dashboard. Then I want to identify particular situations that the car is taking up a spot or the car is leaving a spot. So the spot is either taken or it's open. To do that, I'm going to use an activity. So another one of these programmed boxes called a dwell. A dwell lets me set a conditional expression. So distance is less than 400 millimeters and is greater than 0. So it's not 0. And that the duration is longer than 10 seconds. Because remember, I do not want someone just walking in front of the sensor briefly to trigger this event. I want it to be an actual car. So in real life, this might actually be like 30 seconds or 60 seconds. And then on the other side, on the spot open, I essentially do the opposite. I say if the distance is greater than 1,000 millimeters, so the car is backed away, or if the distance is 0, so there's no object in front of me, and it's true for 10 seconds, then I want to say the spot is vacant. On the other side, the spot is taken. This allows me to trigger what we call collaborations, which are these other two graphical programming boxes that I will use to initiate the driver identification and also opening the parking space up. So let's do the opening parking space up bit. Since I'm already closed, I'm going to pull my camera up here again. And there we go. So there's my car, there's my sensor. I'm going to back away from the parking spot, and I'm actually going to take the car off the table to indicate that it left. So now the car has left the parking lot. You can see the distance has gone to 0. Once this condition is true for 10 seconds, all we're going to do is update our dashboard. So it doesn't really do a lot of actions. As you can see, it's just 3 boxes. updating the dashboard. Boom, I go here, the dashboard should switch from occupied to open. Now, this is important because if I don't know who the person is, I still need to know what parking spaces are open and closed. And there's all kinds of stuff I can do with that information. I could send that information to, for example, a parking meter who will go through and check the cars based on what's occupied or what's not occupied. I can also send that information to the driver who's approaching the location. So I can send information down to the mobile phone to let the driver know which spots are open. And maybe a text message, maybe a push notification, maybe we play an audio file that lets them know. Now, there could be people who are not associated with this application at all, so who aren't using our smart parking app. So for those people, we cannot associate who they are. So I'm going to turn off my GPS tracking here. We only know that the parking space is filled. So let me get my car back. Here we go. We re-enter the parking space. And we check our distance here on our screen. And we should see here in our next readings that it shows that there's a car there. So within 10 seconds, we will go to the spot taken collaboration. And there it goes. And what this now does is sits on what we call an escalation. And the escalation I've configured to just sit there for 90 seconds. Basically, what I'm doing here is saying, if I can't find a driver within 90 seconds, just go ahead and update the HUD with the fact that the spot has been taken, but that there's no driver. Now, the reason why we would want to do this is because imagine if, one, a person doesn't have the application that allows us to at least specify that the spot is taken, or imagine if you do have the application, but it's not running when you park. This gives you 90 seconds to, in your car, turn on the mobile application, which will initiate the GPS coordinates, do the correlation, identify, and send the message to you. Do you want to do electronic payment? Now, if you don't have the ability to do the automated parking, you got to have a fail-safe. We could always create a manual parking feature where you specify I'm parked in A2, and you just manually submit. That way, you don't have to have GPS coordinates turned on, because some people turn that off for privacy reasons or whatever. And now we know we're parked in space A2, and we can do our electronic payment, and we can update our HUD. We know which users are in which spots. We can do all kinds of interesting stuff with this data once that arrives in us. All right, so last thing I want to do is I want to show how we actually create that web interface, and also how we create those mobile interfaces, because they're pretty much the same thing. So here's what it looks like, my mobile interface that you saw there. And my web interface here has these 3 tables, the data tables. What I want to do is add a 4th one, which is going to be a map. The map will show pins based on the GPS coordinates of where my sensors are located. So to do this kind of programming for these widgets, I have to set up what's called the data stream. And in this case, my data stream is just querying my parking spots, which is being updated through my programming collaboration. That's going to include already my GPS coordinates for those sensors. So in order to set a pin on this map, I will set my data stream to those parking spots and my location to that GeoJSON, and I can even say the parking space is the label property for those pins that's going to create. And if I go back to my web application, do a quick refresh, I can launch my smart parking application. There's my map. If I zoom way in, I can see my 3 parking spots, which coincidentally are located in my house, because of course they are. I can't actually go to a parking spot to demonstrate this application. So I hope that seems interesting. That is a very quick overview of a methodology to creating the smart parking application. I don't think the laser rangefinder would actually be useful outdoors. I think what would happen is that someone would really use, say, a sonar sensor or a LiDAR or some other sensor that is both outdoor proof and capable of having an energy source and isn't going to fail if it's raining outside or if there's snow or something like that. So there's better sensors to use. But for a tiny little indoor prototype, I wanted to show the kinds of things we can do just with the software. So as long as we know that there's an object in front of us through a data source, we can create an application that can do all kinds of neat things, like correlate to a driver, give that driver some information, provide a bunch of valuable added services, contact the metering company so that they know they have cars they may have to go out there and check that they've paid. So a lot of additional value we can provide. And I would have to say this took me about 2 or 3 hours to build this little prototype. So a lot more work I can still do on it. Maybe I will, but just wanted to give a quick overview of how that works. If this seems interesting and you want to learn more, just come contact us at vantic.com. You can email me directly, pburma, PBURMA, @vantic.com. Thank you.